Speaking to us today, we have Dr. Antti Laaksonen, who lectures in computer science at the University of Helsinki, but is probably best known to most of us for his books on competitive programming. I know several of us just here on the committee have used the Competitive Programmer's Handbook to prepare for contests, so we're really excited to hear what he has to say. Before we begin, I'd like to again ask anyone who feels comfortable doing so to turn on their video. And then I think that's all from me, so over to Antti for the talk.
Okay, hello, thanks for inviting me here. Okay, so here is my title and here's some background. So at the moment, many people participate in programming contests, and we have nice events like IOI and ICPC, and also online contests like Codeforce and AdCode and so on. And it looks like a good way to learn algorithms. Like you can learn problem solving and independent thinking and skills like that. Also, many things have changed. So if you look at some old IOI or ICPC contests, so they were very different. So it seems like an interesting topic. But for some reason, almost nobody studies it. So it seems that it's a bit strange. We have some interesting things going on, but nobody is interested. So here are some questions. So should we study it? So it's not clear if it's so important topic that we should do it. And if we would study it, so what should we do? What would be the possible topics for research? And it can be a good or bad sign that we don't have research at the moment. Maybe it's a good sign. So we have lots of things we could do. We can write strong first papers. Or then also it can be a bad sign. It's for some reason we shouldn't do that. So it's a bit difficult to say what we should do. But okay, let's say we would like to study this field. So maybe it would be good to try to define. So what is competitive programming? But it's a bit difficult to find any definitions. I only could find one definition from Wikipedia, and it says that it's a mind sport, okay, usually over the internet or local network, and then a bit strange that, at least for me, this sport programmers, I haven't heard it so often, but okay, some people use that also. And then companies like Google and Facebook support it, so they at least think it's important. Yeah, so we have at least one definition that we could study. And actually, we have quite a long history. If you look at IOI and ICPC, so IOI is the contest for secondary school students, and it's more than 30 years old. So first IOI was organized in 1989, and then second famous contest, ICPC, it's for university students, and it's a bit difficult to say when was the first ICPC because it has had many forms, and first it was only a small local contest, but then it has grown. But anyway, somewhere during the 1970s. And both of them have changed a lot. So they have long history and many developments. So maybe we could look at one old contest, IOI 94. I chose this IOI because because it was the first IOI with automatic grading. So before 1994, IOI organizers had to go through every computer and check by hand how does this program work. So it was quite a lot of work. But then from 1994, they have had at least some automatic grading. But in 1994, it was still a bit different. You didn't have any like full feedback or any feedback during contest. So grading was done after the contest. So not like today, but still some automatic things. And it's also interesting to try to solve old problems. So here is the first task from IOI 1994. So we are given some number triangle, and we have to find the maximum sum if we go from the top to the bottom. So here we have one example. We have 5 levels, and here is like optimal route. If we choose this 7, 3, 8, 7, 5, so we get sum 30, and it's optimal in this case. Okay, this was the first task. Then let's look at second task. So we are given a map of a castle, and we have to find out 3 things. First, the number of rooms, then the size of the largest room, and finally we would like to remove exactly 1 wall so that the final room is as big as possible. So in this case we have 5 rooms, and here is some large room with 9 blocks, and if we remove this wall, then we get a very large room. Okay, this was task 2, and then the final and most difficult maybe we have to create a list of 5 times 5 grids where we have some interesting properties. We have to have each row, column, and diagonal has to have some prime number. For instance, here we have 1, 1, 3, 5, 1 is a prime, and also 5, 0, 2, 3, 1 is a prime. So everything here is primes, and then we have some additional things. They should also have some digit sum. Here is 11. 1 plus 1 plus 3 plus 1 plus 1 is 11, and then we are also given some number that should be here, upper left corner. Here is 1. So there can be 1 or more such grids, and we have to find all of them. Okay, if we look at these tasks, so they seem to be quite simple if we compare to today's IOI. So they are actually very, very easy. Here, first task, if we know some dynamic programming, so it's not a big problem to solve it. If you have some experience in competitive programming, so it maybe takes like 5 minutes to code this. And then in this task, maybe the main challenge is how to read input. If you can program a DFS or something like that, then you can easily find the rooms and the sizes, and also you can check for every possible ways how to remove some wall. So also also this seems to be quite easy. And then the final task, yeah, okay, so it's some kind of backtracking. So it's only 5 times 5, so maybe we need some optimization, but still nothing very special here. So this is like 1994. It was about quite easy algorithms, like standard textbook ideas how to do some things, and maybe implementation was a bit difficult, but still not much thinking. But then IO today is something very different. You have to discover some new ideas, and also implementation may be difficult, but the most difficult part is how to invent some new algorithms. I think it's a good development that here we have real challenges now. So it's like 1994. It was like first year of university. So if you can use dynamic programming, so you will win IOI. But today you need almost like you have to do some PhD study at IOI, but only 5 hours time. So it's very difficult. But then why it's so? So how is it possible that IOI 1994 was so easy? Well, at least there are some reasons. So it was a new field, and internet was not existent for many, and so on. So it was a different time, and also if you now know something, so it looks easy. So it's very difficult to say what is easy and what is difficult. Here is my favorite problem. So I think many of you know this. So if you so you have some endpoints in the plane, and you have to find 2 points so that they have the minimum distance. And here you have these 2 points, and we can solve this easily in O(n) squared if we go through all possible points. But then a more difficult problem is to solve it in O(n) log n. And I think many of you can solve it in O(n) log n, but actually before 1975, best professors thought that this is not possible. So O(n) squared is the best possible algorithm for this problem. So it looked very, very difficult. But then in 1975, somebody discovered this trick, so we can divide the points into 2 parts and then do some calculations and then somehow combine them, and we get n log n algorithm. And today it seems quite easy. So it's like so we can do that. So nothing very special, but still before 1975, it was nobody could do it. So it seems that for some reason, if you have some background, or if you know some things, so some algorithms or techniques that are difficult can look quite easy. So I think it's very interesting that problem difficulty can change if you get more information. So something which was difficult can become quite easy. Okay, then something a bit different. So we have a new teaching method. We can learn things through contests. So it looks like we have a new way how we can learn problem solving and thinking. At least many contestants, participants have good skills, so maybe they learn them through contests. But it's not so clear. Is it a good way to learn, or what is the new thing here? And is it just like those people who have skills also participate in contests, or is it like they learn things in contests? So it's not clear how good teaching method it actually is. If we look at any like a traditional textbook, so we find some names like Dijkstra, Bellman, Ford, Freeman, and so on. So always the same names, same techniques. And it's a bit same if we study music. So we have same list of people: Bach, Mozart, Beethoven, Liszt, and so on. And those topics are also important in contests. But then you have some very special topics. Here are some examples. Like segment tree is one of the most important data structures in competitive programming. Then, since we want to use standard library, we have to be able to implement Dijkstra's algorithm. So we only use the standard library heap. So we need some special tricks. Also, a nice group of algorithms are many tree algorithms, like how to easily find LCAs and so on. And then the last example is this Chet's algorithm for string matching. So since we have contest, we have to have some easy ways to implement things. They have to be short implementations, but also efficient algorithms. Segment tree is maybe the more like the most iconic data structure in a programming contest. So we have two operations. At least we can update an array value, or then we have some range. We would like to know something like sum or minimum or maximum or something like that. We can implement both of them in O log n. And the interesting thing is that it's very easy to implement segment tree. So if you know what you are doing, so you only need some lines of code. Like in this case, you have the both main functions here: how to update a value, how to get a sum. And they don't have many lines, but still they are not trivial. So this gets some implementation is especially nice. So it can be quite difficult to understand how it does its job, but it works, and it's easy to code when you know it. So it's like 15 lines of code and you get this thing. So it's a good deal. And you can do many things. You can use segment tree in very many algorithms. Because it has so simple implementation like that. So it has low constant factors. It even can replace many other techniques like sorting and binary search and sets. It would be even possible to teach algorithms so that you first only teach segment tree, and then you try to do everything using it. For instance, you can do sorting, so you don't need quick sort or merge sort or something. You can just always find the smallest element and then replace it with infinity, and you get n log n sorting. But at least I don't know who has made this nice data structure. So I don't have any names to give or any like scientific papers. So it's a bit strange. And also, if you would like to use it in like you are writing a paper and you want to use segment tree, so how can you cite it? So it's a bit different from many other data structures where you have some people have invented it. And if you look at any traditional textbook, you can't find it. So they have a very different approach. So if you want to create something like range queries, so you can just take any binary tree like red black tree or AVL or something, and then put some additional information in nodes. And you will also get some tree that supports O log n operations. It will be very difficult to implement if you look at this code. So it's only 15 lines, and it takes maybe 2 minutes to code. But if you try to implement red black tree, so good luck. Yeah. Okay, then the second difference between traditional textbooks and programming content. So you often have problems like that. So here is one example. You are given a permutation of numbers, and you have to count the number of inversions in O n log n. So it's a nice problem, but then you also have this hint. So modify merge sort. And you can think if this is a good problem. I think it's not, because it has this hint. Everything before hint is very nice, but then you have, if you read this, so this is like the main idea in the problem. So you don't have to think much. Maybe you have to find out some things, but still you know that you have to somehow modify this sorting algorithm. So then in context, if you have some problem statement, so it only defines what you should do. There are no hints like use this and that. No, you should use your own tools and find out how to solve it. So it may be a good way to learn. So you have to think a lot, and it's like real problem solving without hints. But still, I don't think it's not clear which of these ways are like better. So So some people learn like that, and some people learn like that. So both can be fine. And here are some other questions. So if you use code forces, so you will often see people asking those things, and they also often get bad contribution because they seem so like everything is asking same things. But I think they are very basic and important questions. So what is like a good way to learn problem solving, and if you try to solve some problem and you have spent lots of time, so should you read editorial or something, or should you still try to solve it? And also, how difficult problems should you solve, and how can you find them? So I have been a teacher for a long time, like 10 years or more, so I should be able to answer. But actually, I have no idea. So it seems like many people are teaching and many people are learning, and some people learn things, but nobody knows what is like the optimal way. So it seems we have lots of things to study also in this field, how to learn things in problem solving and algorithms, and can we use programming context for that? Okay, if you are in a contest, so then you always know that you are given some problems and then you have to solve them, but somebody has done it before. So it's not like a science. So it can be interesting problem solving, and you can learn new things, but you will not get any like new scientific results. But you can then after contest you can think if you have some interesting topics like competitive programming problems that you can somehow solve in a better way, like how to create a simple algorithm, or can you solve something in something time, or can you solve something without some technique. Here are some examples. So first, this is a classic problem. So you are given a string and a pattern, and you have to find all places where the pattern occurs in the string. So if you have ABC, 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 and then ABC, so they are 3 places here and here and here, and I think the most common algorithm in competitive programming is the set algorithm. So it's quite easy to implement, or at least number of lines is not big, but still it is quite tricky. So it has some, get some minimum here, get some maximum here, I do some magic here, and it has actually like 3 different cases, but somebody has been able to code it like that. But still it, if you should implement it from scratch, so it's not so easy. So would it be possible to create some more like a very easy algorithm? It is still ON time, but you could do it in contests and also in teaching. Like, what is the simplest way do that? So these kind of things, how can you do something easily? It's good in contests, but it's also good in education and understanding how to solve some problem. Okay, then this famous problem, is it possible to create this structure? It's like two-dimensional range query thing. So you have to do these two operations. Add something. Like here, you can add 5 to every element in some rectangle, or then find the minimum. Like what is the minimum element here? So these two operations. And I think somebody asks this every year on Code Forest, how to do that. So it looks like many people would be interested in this and how to do that in O log squared time. But nobody knows how to do that, or I think most people think that it's not possible, but nobody can prove it. So it's like usually if you have contest problems, so you have to do some algorithms, but in this case it may be impossible, and you should somehow show that you can't do that. So it's like a new viewpoint. Okay, then last example. Sometimes you can solve some range query problems in 2 different ways. You can use some technique like Moore's algorithm and solve them in O n square root n. It is quite efficient, but then you can also use segment trees or sets or something different, and then it only takes O n log n. Like if you have to find a number of distinct numbers in a range. It's like the classic problem for Moore's algorithm, but also you can use segment trees. So could we somehow say what is the difference in some problems if you sometimes can use both segment trees or similar to get something like O n log n, and then sometimes you can only get n times square root n. So could you somehow, what's the difference? And also, is it possible to solve some problem in O n log n even if it seems that we would need some O n square root n techniques? Also interesting here is this name Moore's algorithm. So who is this Moore? So I think nobody has any very good sources for that. So who has invented this technique? Okay, then finally my big plan. So at least I'm trying to do some science here. So my plan is to study the history of programming contests, and both like problems and then techniques, algorithms, and so on. And here is my first step. So So step 1 is to create a problem set of 1000 good problems. So it's already online. So first 200 problems are there, but still 800 are missing. And I think this step 1 will take a long time. So at least 5 years, but maybe more like 10 years. So it will be a long study. First, even the first step may take 10 years. Okay, then steps 2 is still a bit unknown. So I have to first do this step 1, and also it may fail like always in science. So if you do something, so you may get some results, but you may also fail. But at least in this case, I think it's a good thing to study, because when you get a set of problems, so it's at least a good thing. So it's at least useful for some people for learning, even if it fails. So something good has been done. Okay, so I'm trying to collect good problems, but what are they? So here are some properties. So they should have simple task statements, like they are like basic problems in contest problem solving. And also every problem should teach something new. So I don't want to collect any 1000 problems, but every and each of them has to be a good quality problem. So that's the most difficult part. It was quite easy to find the first 200 problems. So it wasn't a problem, but then still 800 problems remaining. So I don't know yet if this will be successful. But yeah, let's see. So programming contests and problem sets are good places to find problems, but also like it's not only about contests. It's like more like problem solving algorithms. So also research papers and textbooks are important sources. So it would be great to have something like, if you have some problem, so you could say that this was first discussed by somebody in 19 something, and then it has been in contests A and B and C, and so give some history for each problem. Yeah, and I'm not so certain if this name of this field, competitive programming, if it's good, because at least for me, maybe also because I'm so old, I'm too old for IOI or ICPC. So for me, it's like learning. I want to learn problem solving. Also, I have met many people who are interested in algorithms. They learn them, and I think they could learn a lot in programming contests, but they don't want to compete. So it seems that yes, of course, it's not a good idea if we have competitive programming. So competition is an important part. We can't remove it. but still I think we have something more, like more like problem solving and how to think and things like that. So it's like, I think it's good that we have contests. They are nice, but we could have something more. And if we want to get more people doing these things, so maybe it's not a good idea to too much focus on contests, more on learning. So this is what I have learned, and also I have written some books, and I think if I could do it again, so I would change the title. So I wouldn't use like competitive programming in title, but something like how to become a good programmer, or how to learn problem solving. Yeah, but different people have different goals, so it's nice that we have this long history of contests and many nice things, and at least many interesting things that you could study. And I'm trying to study something, and if maybe some of you would also like to study something in this field. Yes, thanks. Do you have any questions? You can ask now.
Great, thank you very much. That was really interesting. Thanks. If anyone has any questions, you can put them in the chat, or you can probably just unmute yourself and ask away.
So you asked this problem about finding a simpler alternative to the Z algorithm for string matching.
Yeah.
Wouldn't you say polynomial hashes do this?
Yeah. Okay. So we have this. Okay. We have, yes. Actually, we have two different techniques that we usually use in competitive programming. So we can use this chat algorithm, or then we can use hashing. And yes, but I don't like this hashing technique so much, because it's somehow like you hope that it works, but and usually it's a good technique, but somehow this chat is better, because it's like it always gives the correct result. So yes, I agree. Hashing is often a good algorithm, but it's not like a complete solution for this problem.
Yeah, it's good enough for contests, because you'll probably get the right answer with.
Yeah, that's
true.
It's
not deterministic, sure.
Yeah, I agree.
All right, I can ask a question. So the UCCPS heard from Stephen Skinner, I think it was a week or two back, and he was mentioning the kind of drawbacks about competitive programming, and that sometimes the problems are like so specific that you get good at solving competitive programming problems, but then you're not so good at solving like other more open-ended problems. What are your thoughts about that? Are some people too focused on the specific competitive programming problems that makes them kind of worse at more general problems?
Yeah, that's an interesting question. So yeah, like I said here, so it's not so clear if it's a good way to learn, but at least I have seen many of my students, so they have first been like contest participants, and they have learned things, and now they are doing science. So at least it's possible, but it's very difficult to know. Maybe they are just like they have good skills, and they have done contests, and now they do science, and there is no direct connection, maybe, or then they have learned it through contests. But I don't think it could be a bad thing. You learn problem solving skills, and you learn important techniques and so on. So at least you learn some useful. But then if you want to do some science, so it's different. So you may need to learn something more. So it's not enough to learn all competitive programming physics. But I would say in most cases, at least what I have seen, it looks like it's a good way to become a scientist.
Thanks for the answer.
Thanks. So I have another question. Do you think you would encourage all of your students, or perhaps anyone learning algorithms, to try out competitive programming, or do you think it's not for everyone?
Yes, I have had this problem with it's not a problem, but I have met many people who don't want to compete. So if you want to learn something, so you don't have to want to win a contest or be the best. So I think we would need some way to teach things like that, but not like in a contest setting. But there are many good things like learning independent thinking and problem solving and so on. But for many people, contest is not a good combination. So I don't think it's a good idea. Like if you teach something at university. So some people like it and it's nice, but many people also don't like it. So it's very different for different people, and it's good to understand that not even if we think that it's nice and it's nice to compete and win and so on. So some people or many people don't think so.
Thanks. Okay, have we got any other questions? Anyone wants to ask anything in the chat? Otherwise, shall we wrap up there? Thank you very much for speaking to us, Antti. It's been great having you. Really interesting talk. I hope everyone's enjoyed as much as I have.
Yeah, thanks so much, Antti, for the talk.
Thank you for inviting me. It was fun. Thanks.
Yeah,
Bye-bye.
really interesting to hear from you. Bye.